Assalamualaikum and good day. Today, my team members Nur Amira Syafiqah, Nur Hani, Nur El Ain, and I, Nur Kisina Anisa, will be presenting about the introduction to chemical engineering and also distillation and its applications. Alright, so we'll first look into the introduction to chemical engineering. Let's hear a brief insight about it. So, what is chemical engineering? What it is all about? So generally, chemical engineering is a combination of chemistry, biology, physics, and mathematics to create a sustainable environment using brilliant ideas. But you might still be blurry of how does it contribute to our lives. So let's talk about these 5 main points here. The first point here is to provide clean water. Clean water is essential to all living things, so we need to know the correct sanitization process in getting the clean water. The second point here is better healthcare. We get to see this when we want to provide medicines to patients that needs a certain dosage. Third is the food research. This is because we add a lot of food additives, right, so that we can improve the food flavor. So it involves chemical engineering here. The fourth is energy generation. You could see that now coal can be used as a cleaner energy source. And the last point here is designing products and processes. In chemical engineering, you will be familiarized with many unit operations such as distillation column, heater, mixer, and a lot more operation units. Here, you can see the learning processes that you will go through when learning chemical engineering. The first and the second point might be very usual, which are learning theories in lectures and also doing lab practicals. But the third point here is you will get to discover new technology and softwares that are used in chemical engineering. The fourth one is you will investigate how does this study contributes to social and environmental impacts. And the last one here is you will plan industrial strategies so that you will have a high efficiency. Now, we will go into the distillation and its applications. So firstly, we will look into the distillation tower. Distillation tower is made up of several components that will allow the separation of different components in a liquid solution based on the different boiling points. Let's look at the figure here. This is how distillation tower works. So let's say that we want to separate ethanol and water. The vapor phase will have high concentration of ethanol. Why? This is because ethanol has lower boiling point than water, so it will turn into vapor much faster than water. And this explains why the liquid phase will have high concentration of water.
Since we know the definition of the distillation tower, now we're moving on to the types and function of the tower. So distillation has two types of column, which are batch column and continuous column. Batch column is the method of separating component in a mixture batch-wise, while the continuous column is a method separating the component in a mixture using a continuous process. So there are 4 things that differ between batch and continuous. Batch require 1 distillation column, while continuous require n-1, which n is the number of components need to separate. The efficiency of batch distillation is low compared to continuous distillation column. Continuous distillation is less flexible than batch distillation, since there are several columns that used for each component separate to the mixture. After all the distillation process are finished, batch can use for different component quickly compared to the continuous, which takes a long time to change the mixture. Then to summarize this, the difference between batch and continuous distillation is that batch is done in a batch-wise, whereas continuous is done as a continuous process.
Okay, hello, my name is Hani and I'll be explaining about the component of distillation tower. So, before we go straight into the component, let's take a look at the flow diagram first. Okay, now we see this is the flow diagram of distillation column. As we know, distillation is a process of separating a mixture between 2 or more components by heating it with a temperature between their boiling points. Okay, let's see one example right here. This example shows a mixture of water and ethanol is boiled at 90 degrees C with atmosphere pressure. So what will happen next? So let me explain. Ethanol that has a 80 degrees C boiling point will change into vapor and then will be collected and condensed. However, water that has 100 degrees C boiling point will be separated and remain as liquid. Okay, now since we already know how the separation process occurs, so we can moving on into the component.
The first component is vertical shell. Vertical shell is where the separation of liquid component takes place. The vertical shell will houses the column internal together with the condenser and reboiler. Next is the trace. Trace are part of the internal column and it is used to enhance the component separation. Moving on into the condenser. Condenser is used to cool down and condense the vapor that living at the top of the column. Next is the reboiler. Reboiler is used to provide the necessary vaporization for the distillation process. And lastly, reflux drum. Reflux drum is to hold the condensed vapor from the top of the column so that the liquid, which is the reflux, can be recycled back into the column.
These are the several applications that use distillation in industry. Firstly, petrochemical fuels. Second, fragrances and essential oils. And lastly, pure drinking water. Petrochemical fuels. What is petrochemical fuels? It is the manufacturing of gasoline, diesel and other fuels and chemicals is a major industrial use of distillation. The procedure involves feeding the crude oil, which is a mixture of different components, into one end of refinery. The lighter components like kerosene, gasoline and lubricating oil are removed in each distillation phase, while leaving the heavier compounds like tar on the bottom of the tower. This is an example of how distillation works on petrochemical fuels. The process is, after oil is superheated, it becomes vapor and the vapor fed into the distillation unit. After the vapor rise and cooled, it will become a liquid and the liquid will be separated and collected by the trace. As you can see, the lighter component like gasoline, kerosene will be on the top of the tower, while the heavier oil will be at the bottom of the tower. Next is fragrances and essential oils. How do we get the smell of the fragrances? It is by extracting perfumes from plants and other biological materials may be done by using vacuum distillation. This is because these compounds are very delicate and can degrade at high temperature. Therefore, vacuum distillation is an excellent method for extracting them from natural sources. These are the examples that use fragrances and essential oils in our daily life, such as soap, air freshener and also in our perfume. Lastly, pure drinking water. It is to create safe drinking water for us. Using distillation to purify water is also beneficial in industrial applications. For example, removing minerals and other impurities from the water can help increase the effectiveness of certain type of mechanical equipment. This is an example of laboratory experiment on how to get distilled water. In conclusion, now we know what is chemical engineering, what is the meaning of distillation tower, the type, the function, the component, and also the applications that used in industry. I hope you all had fun and gain more knowledge with our video. That's all from us. Thank you.